Hello everyone, this is your tutor AB. Today we're going to be solving a problem from the May 2023 IB Chemistry HL examinations. This is a paper 2 problem. Let's get started. A series of experiments were carried out at different temperatures and the rate of reaction in moles per decimeter cube per second was determined for each. The rate constant for the reaction of propanone, given by this expression there, with iodine I2 was calculated, and the process data is represented in the following graph. So on this graph right there. Question: determine the activation energy for this reaction stating the units. They're telling us that we can use section 1 and section 2 of the data booklet. Okay, so let's get started. We're given a graph with a straight line. What can I do with this? Let's think. In your formula booklets, is there an equation like this? K is equal to AE to the power of negative EA over RT. Do you see some equation looking like this? Well, this is actually your Arrhenius equation, right? This is your Arrhenius equation. But what does this have to do with anything? Well, let me show you. I can actually rewrite my Arrhenius equation into a form that looks similar to something we learned before. Let me take the natural log on both sides. ln K is equal to ln A minus EA over RT. Now this was just derived using your laws of logarithms. Okay. Now let me rewrite this expression one step further. ln K is equal to negative EA over R times 1 over T plus ln A. Now, does this expression, does it look similar to something? Let's think. Does it not look like y is equal to mx plus c? Are they not the same almost? Think about it. Your c, which is your y-intercept, is equal to ln A. Your m, your gradient, is equal to negative EA over R, and ln K is equal to y. Through direct comparison, we can actually see the correlation between the ln K is equal to negative EA over R times 1 over T plus ln A and the equation for a straight line. Now, look at that. We are given a straight line in our graph. Can we not use this equation that we just derived to find out negative EA over R? Why negative EA over R? Well, that's your gradient, and gradient is something that I can very easily find on this graph. So let me find out what is this gradient, and I will tell you what happens next. Well, the gradient or slope, I'll call it slope, is actually equal to rise over run, and we do this rise over run with 2 points. Let's take, for instance, that point right there and this point right there. Okay, so what is the rise over run? Well, that's my rise, which is negative 2, and that's my run. And my run is going to be 0.0035 minus 0.0032. That gives me 3 into 10 to the power of negative 4. Now, doing rise over run, what do I get as the slope? Slope comes out to be, putting this on my calculator, rise over run is 6666.67. Okay, and this has some units, but let's not worry about that for now. This is what rise over run is equal to. Then I know that this rise over run or slope is actually equal to negative EA over R. So that's a negative number, sorry. So negative 6666.67 is equal to negative EA over R. Now I can cancel out the negative signs from both sides. And if I times both sides by R, which is the gas constant, I'll be able to isolate EA on its own. So EA comes out to be 666.67 times 8.31 over 1000. So you can over 1000. Now I'm going to work with kilojoules per mole, but if you want to work with joules per mole, you can do that as well, but you would have to make some changes in the previous working outs. Okay, but I like to work with kilojoules per mole. So let's see, what do I get? If I say EA is equal to, and let's put this on my calculator, I find that my answer comes out to be 5,600 kilojoules per mole. Sorry, not kilojoules per mole, it's actually joules per mole in this case. Okay, or in kilojoules per mole, I can say it will be 6 kilojoules per mole. Okay, so depending on whether you have 1,000 or not have 1,000, your number will change. You can either write it in joules per mole or you can write it in kilojoules per mole. The only thing that changes is the factor of the zeros at the end. Okay, thank you for watching. Please like and subscribe. If you have any questions, leave it down below and I'll answer it as soon as possible. Thank you for watching.